Wall Street has a $30,000 a year religion. Its software traders spend more time with than their families, staring into a closed ecosystem of market intelligence. Then, an artificial intelligence startup named Perplexity claimed it could replicate that exact ecosystem for a fraction of the cost. The finance world erupted, calling the idea laughable and aggressively defending their expensive terminals. The media quickly framed this as a turf war between traditional finance veterans and Silicon Valley developers over who gets to control the flow of data. Both sides of this conflict process information in the exact same way. By arguing over which platform has the better interface, the market is overlooking a shared catastrophic blind spot. Both systems operate as honeypots. They pull in scattered digital fragments, exchange prices, news articles, and chats, to concentrate them into a single beautiful dashboard. These companies are following the strict instructions of the information age: gather the data, make it searchable, and sell it back for a profit. However, these pristine digital honeypots simply cannot capture the real-time, messy, physical friction of the living world outside. Every trade executed on a terminal and every prompt fed into an AI assumes those digital fragments represent the whole picture. That assumption makes massive physical risk invisible to the people making the bets. This diagram represents a single digital action. Let's trace a theoretical transaction, approving a new data center. That click requires a physical array of high-density server racks. Those servers need constant power from a congested electrical grid, vulnerable to sudden spikes. To keep those servers from melting down, the facility draws millions of gallons of water from the local watershed, a living system steadily drying out. The capacity of that transmission line and the depth of that reservoir are missing from the financial models. They are not priced into the transaction. By severing the digital numbers from their physical footprint, the market has divorced its intelligence from the reality keeping it alive. This systemic blindness is a feature of the information age, built directly into the architecture of our data models. We prioritized extraction over completion, building systems designed to strip away the messy physical context of the world and reduce living networks into isolated numerical values. We see the human consequences of this extraction in the communities hosting these data centers. When municipalities offer deep tax incentives to attract tech infrastructure, local school districts often absorb the hidden costs on depleted budgets. Eventually, a high-speed trade or a massive compute job will fail because a regional power grid buckled under the strain of a severe heat wave. When that collapse hits, society will blame the trader or the CEO, missing the fact that the failure was seeded years ago when we decided that fragmented data was enough. The tech and finance industries are currently fighting the foundation of their own customer base. The processors generating AI models and the mainframes executing trades plug into the exact same stressed grid and drain the exact same fragile watershed. The intelligence required to map and prevent these failures already exists. Scientists at the USGS track these risks in real time, but their data is locked away from the financial platforms. No single corporation has the authority to force federal science agencies, independent grid operators, and private tech platforms to suddenly synchronize their databases. Because one company cannot bridge this gap, millions of customers remain exposed to a foundational collapse. A sovereign network provides a structural solution to this disconnect. This is a co-built architecture where hyperscalers, utilities, and communities merge their isolated data streams into a single cohesive view. Adopting this model allows companies to keep their current terminals and business values while gaining the context they currently lack. Processing power and chip speed have outpaced our ability to categorize risk. Outdated classification rules now hide the physical vulnerabilities that could collapse the entire network. Surviving the next phase of the information age requires a complete view of the board.